All right, welcome to another edition of Math with Marcus. Thanks for joining me today. We're going to do a problem from course 1, chapter 7, problem number 88. It says, on graph paper, draw a rectangle with a width of 5 units and a length of 7 units. They give us a great Desmos tool that we're going to use in a minute. Then it says for A, draw a new rectangle that is an enlarged copy of your original rectangle and has a length of 13 units. So we need to take our rectangle and multiply the length and the width by something. We're going to enlarge it. So we're not just going to add units to it. We need to think about it as a multiplier. We're looking for the scale factor. And it says, how would you calculate the width of your new rectangle? So let's use the Desmos tool for part A, and then we're going to show you how to do it just by hand. So here they go. They've got this rectangle laid out. The width is 5 and the length is 7. And we're going to try to use this sliding scale and try to get our length to 13 units. So let's take it and let's slide it. Whoa. So close. Right up. Let's see if we can go. There you go. Oh, so close. All right. So we need to adjust it a little bit because I don't think it's quite 13. Whoa. I don't think it's quite 13. So close, right? So let's go, maybe instead of 8.5, we go 8.6. And that's a little bit too much. So 8, a little bit more. So 8.5 was good. What about 8.5.5? Not quite enough. So what about 8.5.7? So that is super close. Look at that. 1/1000th away. So let's just add a 1 there and see if that gets us there. Yep. All right. So we've got 1 and 8,571 thousandths. I'm going to round that and say that, you know what, that's about 1.9 or 1.86. So about 1.9. So that's our scale factor. And when we use that scale factor, when we multiply the length by this number, by 1.9, 1.86, we get 13 and 9 3/10. Round that to 9 3/10 units. So that's what our width should be. So how could we calculate that? How could we get that is what we should have? Well, let's use ratios. So if we compare the length to the width, we can write our original rectangle as 7:5, right? A length of 7 and a width of 5. And we know that where we're going to is to a length of 13, and we're being asked for the width. So this is great for a ratio problem. And we could just use a giant 1 to see what this equivalent ratio should be. So how many times 7? So 7, how many times will get us to 13? That is a division problem for sure. So let's take 13. And let's divide by 7 and see how many 7s are in 13. Well, there's almost 2, right? There's almost 2. If it was 14, it would be 2 of them. So 7 times 1 is 7. Subtract and we'll get 6. Let's keep it going. So bring down a 0 and bring up the decimal. 7 goes into 60 8 times. 8 times 7 is 56. Remainder of 4. Let's keep it going. Bring down another 0. So 7 goes into 40 almost 6 times. So about 5. 7 times 5, 35. Subtract and we get a remainder of 5. Bring down another 0. 8 goes into 50 7 times. 7 times, and 7 times 7 is 49. Remainder of 1. So that's pretty darn close right there. So what we might do is say that the scale factor is about 1 and 86 hundredths. That sounds good for me. So we're going to take this and say that 7 times 1 and 86 hundredths is 13. So what is 5 times 1 and 86 hundredths? Well, let's do that, and that'll get us the width. Let's fix that. Here we go. So we've got 5 times 1 and 86 hundredths. Do not need to line up the decimals when multiplying. I multiply like it wasn't even there. So 5 times 6, 30. 5 times 8 is 40. 40 plus the 3 is 43. And 5 times 1 is 5. 5 plus 4 is 9. Then you say, all right, well, how many numbers are behind the decimal place? There's 1, 2 numbers behind. So in your answer, we need 1, 2 behind the decimal place. So we know the width is, we know that the width is 9.3. Since we approximated, since we did not get an exact value, we should say really darn close to 9 3/10. So that's how you do it by hand. All right, thanks for joining, guys. Stay tuned for the next episode.